a little bit now with the subsets of the real numbers, and then we're going to reduce a fraction to lowest terms. Over here on the board I've written for this set right here, that is this set of numbers, list all the, first of all, whole numbers. Well, the whole numbers are the numbers 0, 1, 2, 3, so on and so forth. They're all positive, no fractions, no decimals in there, 0, 1, 2, 3. So if I look up in this set, I see that 0 is there and 1 is there, so the whole numbers are, I'll put down 0 and 1. So 0 and 1 are the only two whole numbers that are in this set. Now the next question is, which are the integers? Well, the integers are the whole numbers plus the opposite of all the counting numbers. So it goes up from negative infinity, negative 3, negative 2, negative 1, 0, 1, 2, 3, so on and so forth. So as far as integers are concerned, I have negative 3, 0, and 1. So negative 3, 0, and 1. Those are the integers that are in this set right here. Now, rational numbers, those are all the numbers that can be written as the ratio of two integers. So it includes all the whole numbers plus all the fractions. So I'm going to say negative 3, negative 2.5, since that can be written as a fraction, 0, 1, whoops, that's 1, and 3 halves. So negative 3 is a rational number because it can be written as the ratio of negative 3 to 1. Negative 2.5 is a rational number because it can be written as a lot of different ratios, but one of them would be negative 25 to 10, 0 to 1, 0 to any number really, and 1 to 1, 3 to 2. So any number that I can write as a fraction, that is the ratio of two integers, is considered to be a rational number. Irrational numbers are all the numbers that you can't write as the ratio of two integers, and those are the numbers that have special symbols for them. For instance, this symbol right here, which is, we say, positive square root of 15. So that's the only irrational number. As far as real numbers, they're all real numbers, so I'm just going to say all of them. And that exhausts the set of real numbers. All the points that are on the number line can be named with whole numbers, integers, rational numbers, irrational numbers. They're all real numbers. There's bigger sets of numbers than this, and we'll encounter a little bit of that later on in the course. But the real numbers is the set that we're going to work with most often in here. The next problem we want to do is a fraction problem reduced to lowest terms. 525 over 735. So I need to begin by factoring the numerator and denominator. So let's see. 5 divides this, so that's 5 times 105, it looks like. This is 5 times, let's see, it's going to be 147. Now, 105, that's divisible by 5 again, so I have 5 times 5 times, 5 divides into here 21 times, 21 factors into 3 times 7. Okay, here I have 5 times 147. This looks to be divisible by 7, so I'll divide 7 in there. It's 7 times 21, so I'll factor that again, 3 times 7. So here I've taken this fraction right here and factored the numerator and denominator into the product of prime factors. None of these factors can be factored any further. Now, to reduce this fraction to lowest terms, I simply divide the numerator and denominator by any factors they have in common, and I show that by doing this. I draw little slashes through the 5s. That's common to the numerator and denominator. That's 7 and that's 7. That 3 and that 3. So this shows that I've divided the numerator and denominator by these factors. What's left in the numerator is 5, and in the denominator 7. So the answer to that problem is 5/7. That's the fraction that's equivalent to this fraction right here, but it's in lowest terms. So there's a quick look at some of the subsets of the real numbers and how to reduce fractions to lowest terms.